called rationalizing the numerator. Does anyone remember the process of rationalizing numerator or denominator? What does it involve? How do we rationalize an expression like this one? The square root of 2x plus 2h minus 1 minus the square root of 2x minus 1. How do we rationalize this? Anyone remembers?
Do you eliminate the square root?
We cannot do that. The
Raises the
process,
second power.
we cannot square. No, that's not possible. It's only because, see, if I have x equals 2 and you want to square both sides, that's okay. But if I have an expression like, let's say, 4 over 7, and you say, oh, just square it, is this equal to 16 over 49? No, it's not. So the process of rationalizing the numerator requires us to use the conjugate. So this is a minus b. We need to multiply by a plus b. So the same thing, the square root of 2x plus 2h minus 1, but plus the square root of 2x minus 1, and we have to divide by the same quantity. 2x plus 2h minus 1 plus the square root of 2x minus 1. All this, multiplying by this, will not affect anything. Will not affect the answer. Why? This is 1. Multiplication by 1 will not change anything. Squaring will not make this equal to that. But multiplying by 1, I still have this. There is no change. But it will look differently. So h times this, I just have to copy it. So I had a minus b, I'm multiplying by a plus b. Does anyone remember what does the product a minus b times a plus b equal to? A minus b times a plus b, or the other way around, it doesn't matter. A plus b times a minus b. Anyone remembers the answer here?
A squared plus AB.
It cannot, we're not distributing. You can distribute it and just give us the answer. The reason why is because this is well known. But okay, let's do it the first time. So a times a times b, a times negative b, and then negative b times b. So this is the difference of squared, which is a squared minus b squared. So this comes from beginning algebra. A minus b times a plus b, or a plus b times a minus b is this. Now, we're going to go back to our multiplication. The square root minus this times the square root plus this. And remember, we have to get a squared minus b squared. So can anyone square this for us? The square root of 2x plus 2h minus 1 squared. Can anyone square that for us? What should I write? When we square this quantity, based on the formula, the difference of squares. Difference of squares. Can anyone square this quantity for us? And I'll write it here. Anyone would like to try? It's okay if you're wrong. Anyone? Anyone? Anyone, please try. Can anyone square the square root and tell us what to write? Anyone, please? No one wants to square the square root.
Would it just be the same formula but without the square root?
Of course. Minus. Can anyone square the second one?
2x minus 1.
Very good. Awesome. Great job. I'm going to continue with the triangle. Now I distribute. It's very important to take it in 2 steps, or if you want, you can distribute from the beginning, but make sure you distribute to both. So we have 2x plus 2h minus 1 minus 2x and plus 1. Oops, I put 2 pluses in there, and there was no need for 2 pluses. Sorry. Good. So plus 1 divided by h times this. No one can change that. No one can simplify the denominator. 2h minus 1 plus the square root of 2x minus 1. So remember what we said. Every time I determine the difference quotient for any function, all terms without h must simplify in the numerator. Let's see. Good. That is done. All terms that do not have h are gone. Number 2 has to happen now. H from the denominator must simplify. Okay, let's see. I will write it again. I have 2h in the denominator. I have h and the square of 2x plus 2h minus 1 plus the square of 2x minus 1 in the denominator. And here's what I do next. 1 and 1. So the final answer is 2 over this whole thing. The square root of 2x plus 2h minus 1 plus the square root of 2x minus 1. Notice there is still an h left somewhere, or maybe more. But not this one that was in the denominator. No, that one is gone. And no term without h. Some terms with h may go away, but definitely all terms without h must go away, and they are. So the numerator is just 2h over h. And we simplify, and this is the final form. What does this mean? What is all this? Well, that means is the almost instantaneous rate of change. Like I'm driving and you're calling me and I'll tell you the speed that I'm driving at that instant. So it's almost, the difference quotient is almost the rate of change of this function. The instantaneous rate of change, not the average, the instantaneous, almost. So again, this was a good choice, a slightly sophisticated problem because we had to go through all these steps again. So a lot of steps here. So please keep in mind the difference quotient, what it means, and how we find it for several functions. We looked at 3 functions, a radical. Last week we looked at a rational, and you had on homework, you had a polynomial, the simple polynomial. Okay, so the last thing I wanted to say for tonight is R.5, nonlinear functions.
I'm sorry, was the last equation we did, that was all difference quotient?
Yes, all these steps till here, till the fully simplified form. Yes. So this was the difference quotient fully simplified. We started with this, it was this, then we rationalized, then we multiplied, then we simplified some more, and we got to the final form. Very good question. Thank you.
Okay, thank you.
Thank you. Okay, so what I would like to review for the nonlinear functions, yes, we have a lot of functions to look at, but what I would like to review with you is properties of exponents. So let me look at the time, 10 minutes, oh, that's fine. I'm looking at the video to make sure that it doesn't exceed 20 minutes. Okay, so one thing is, for example, a to power n times a to power m. Can anyone tell us it's a to which power? Anyone, please? N plus m. If we have a to n over a to m, is a to which power? Anyone, please? Yes, the numerator minus the denominator. What about a to n? Everything raised to m. A to which power?
Second.
Say it again.
Second power.
N multiplied by m. So when we multiply two exponential notations or exponential expressions with the same base, we copy the base and we add the exponents. When we divide, we copy the base, we don't do anything to the base, we only copy it, and we subtract. From the exponent of the numerator, we subtract the exponent of the denominator. If we have a to n, everything to m, we copy the base and we multiply the exponents. What about a to negative n? What does that mean? A number raised to a negative exponent. What does it mean? Anyone remembers?
Wouldn't it have like the n?
This one is a fraction, is 1 over a to the nth power. What about the nth root of a to the mth power? Anyone remembers what this represents? A to which power? So a radical is a power. Which power? A raised to which power is the nth root? N, so this is n, and this is m. Sorry about that if it's confusing. So n, my n has 2 loops, my m has 3 loops. So the nth root of a to the mth power. I know it's a full mouthful. So what is this? Anyone remembers this? It's a fraction. The power is always in the numerator, and the index is always in the denominator. So as an example, if I want the square root of 3, how would you write it? As 3 to which power? It's a root, so the power has to be a fraction. What is the fraction here?
One-third.
Yes. So it's 1/2, you mean? 1, there is a 2 here. And there is a 1 here. So the power is the numerator, the index is the denominator. One more. So let's say the fourth root of 5 to the 3rd power. This is 5 to which power?
3/4.
Yes. Now let's try one reverse. So what if I have 5 to negative 1/3? Let's address the negative power first, and then the fraction. So look at the negative power. What will you tell me to write first for the negative power?
1/5.
1 divided by 5 to 1/3. Good. Now let's take care of 1/3. What will 1/3 be? 1 over what? If it's a fraction, it must be a root. If it's a fraction, it must be a root. How do I write 5 to 1/3? The what? The cube root of 5. The cube root of 5 is 5 to 1/3. The square root of 3 is 3 to 1/2. So I probably ran out of time. I have 2 minutes. So let's see if we can just look at one example if we have time. So I'm hoping I'm not logged out. I'm hoping. I just wanted to look at one example if we have time. If not, we'll do this on Tuesday. Square root. We're going to look at those graphs. I just want to look at something like changing back and forth. One example. Because the functions are very clear. We're going to look at those in absolute value function and a rational function, and in the next chapters they will come back. We'll go back to those functions. Okay, finally. Okay, so let's choose one example. Rewrite each of the following as an equivalent expression using radical notation. Just choose one and then we'll stop. Any of these problems that you want to work on. I do not consider R.5 finished. It is not. So you don't have to finish the Pearson. So can anyone choose one problem from here so we can stop afterwards?
48.
We want to use 48, so t to 2/5. Good. Can anyone tell us how to change this into a radical? We know it's a radical. How do I know? Because every time the power is a fraction, this must change into a radical. Can anyone tell us how to change it? Tell me what is the index.
5.
That's it. So it's the 5th root of t to the 2nd power.